Hey everyone, my name is Lila and I'm currently in high school. I know chemistry can be difficult for some students, so I create short videos to break down concepts in a simple and understandable way. Let's get started with today's video. In today's lesson, we are going to break down Gay-Lussac's law. This law shows and explains the direct relationship between temperature and pressure. When a gas is heated, the particles move faster and collide with their container's walls and each other more frequently. This increased amount of force then leads to a rise in pressure. The general formula for Gay-Lussac's law is the initial pressure of a gas divided by its initial temperature equals the final pressure of a gas divided by its final temperature. When you are solving problems or equations relating to Gay-Lussac's law, you will need to understand these formulas and keep in mind that when working with temperature, the units always need to be in Kelvin. To better explain these formulas, I'm going to provide an example problem as a visual. The first thing you need to know is that whether you are finding a new pressure or temperature, you will need to figure out the old variable and the necessary adjustment. The old variable will most likely already be given to you, although in some cases you may need to work backwards to find the old variable instead. In this example, we are given the volume, old pressure, old temperature, and new temperature. Since this is a Gay-Lussac's problem, we can ignore the volume because it remains constant. We will be solving for the new pressure. To start any problem, I like to write out my variables on the side like this. And then I will fill in any information I am already given. Both of these temperatures are in Celsius, so I need to add 273 to convert to Kelvin. Now I'm going to set up the foundation for my equation. This will be the same setup for any problem. I am going to fill in the first blank with the old number of the variable I am solving for. So in this case, I'm going to write 110 torr because I know that I am solving for the new pressure. Remember to always write your units. The next part is a bit trickier. Since we are solving for pressure, we need to find the temperature adjustment. It is crucial to understand the relationship between pressure and temperature to figure out the adjustment. These variables have a direct relationship, so I know when one increases, so will the other, and when one decreases, the other will too. Because I am given both the old and new temperature, I am able to observe that the temperature is increased. Since my temperature increased, I know my new pressure is going to be greater than 110 torr. When you are given a Gay-Lussac's law problem, you are always going to fill in these last two remaining blanks with the information of the variable you are given and are not solving for. The new variable will go on the top and the old variable will go on the bottom. For my problem, I know I'm going to fill in the blanks with temperatures because that is the variable I'm not solving for. My new temperature is 400 Kelvin, so that goes on the top. And my old temperature was 300 Kelvin, so that goes on the bottom. Now that I have my equation set up, I can plug it into my calculator. Make sure to put the variable adjustment in parentheses to get the correct answer. I got an answer of 146.7, and my units are going to be torr because that is how pressure is measured. Let's try another problem. For this one, we are solving for a new temperature. We are given the volume, old pressure, new pressure, and the old temperature, although we need to add 273 to convert to Kelvin. Even though we are given the volume, it remains constant, so it is not needed to solve this problem. Before we start, I'm going to set up my problem. In this first blank, I'm going to write my old temperature of 300 Kelvin. By looking at my old and new pressures, I am able to see that there was an increase, which means my temperature will increase as well. Because I have a direct relationship, I'm going to put my new pressure of 770 torr on the top and my old pressure of 630 torr on the bottom. Now I'm going to put this in my calculator, which gets me an answer of 366.7 Kelvin. But we're not done yet. This problem wants the answer in Celsius, so we need to subtract 273 from my answer to make this conversion. After doing this, your final answer should be 93.7 degrees Celsius. I have one last example for this video, which is going to be a try-it-yourself problem. I will leave the problem up on the screen for a moment, and then we'll display my work and answer. Feel free to pause the video if you need more time. Okay, I'm going to fill in my work and the answer so you can compare your answer to mine. If you were correct, you should have gotten negative 4.63 degrees Celsius and had your equation set up like this. That's the end of today's video. I hope this has helped to make Gay-Lussac's law and the relationship between pressure and temperature easier to understand. Check out my channel for more chemistry breakdown videos like this, and feel free to ask any questions you have in the comments. Thanks for watching.